How's everyone doing? This is Carlos here with Codecademy with another lesson on Visual Studio and Razor Pages. Now, coding an application from start to finish and expecting it to compile without any errors is extremely unlikely. Making mistakes when programming is simply part of the process. Today, we're going to learn different ways to detect and remove existing potential errors in your code. Now, when it comes to debugging, Visual Studio shines with its lengthy list of tools that we can use to track and remove any bugs in our code. Today we'll be exploring how to use breakpoints, how to step into, over, and out of functions, and how to quickly navigate around our project. We'll also be taking a look at different kind of debugger windows that provide us with very useful information. So without further ado, let's go ahead and get started. Okay, so I have a small application here, and the first thing we're going to do before we start diving into the code is to check what version of Visual Studio we're running. We can do this simply by clicking on the Visual Studio tab on the upper left corner and then going into About Visual Studio. Here you'll see the information about the Visual Studio that you're running. You can see in my case I'm using the Visual Studio for Mac Community Edition, and I'm using the latest build at this moment, which is build 7 or version 8.5.5. Now if you want more details, you can click on Show Details, which will give you more information on what frameworks and runtimes were installed. You can see I have the .NET Core runtime and the SDK installed. And if you're in a Windows machine, you can check the information about Visual Studio by clicking on Help and then going down to About Microsoft Visual Studio. And you'll find information about the Visual Studio version and other tools and frameworks you have installed. Back in our application, you'll see I have the generated pages and other folders and files that were created when we created a Razor Pages application. So you'll see I have an About page along with the page model for it. And inside the page model, we'll see a few functions that I wrote that we'll be working with. We'll be moving around these functions using Visual Studio's tools like the breakpoints, but we need our application to run first before we do so. This means our app needs to be compiled and built in order to actually run. So let's take a look at what it means to actually build a project and the different ways we can build in Visual Studio. With Visual Studio, we're able to build, rebuild, and clean a project. Now with building, this means that we compile the source code to produce .exe and .dll assembly files, which we'll look into in a minute. So we can build a project by clicking on the Build tab and then selecting Build All. This will compile our human-readable code into machine-readable code so that our computers can run it. The machine-readable code is organized into files called process assembly files, which have a .exe file extension, and library assembly files which have a .dll extension. So if we open up our project and our Finder and navigate into the project directory, we'll see that we have a bin and an object folder created for us. And if we take a look at the bin folder and navigate into the project and into Netcore App 3.1, we'll see the library assembly files created for us. Now, if you're using Windows, you will also find the executable files which have a .exe extension. In this case, we'll find .dll files along with some .json files that contain some configuration for a project, and we'll also find PDB files, which stand for Program Database Files. And PDB files essentially contain information for the debugger to work with. So initially for the first build, the entire project is built. All consecutive builds are treated as incremental builds, meaning that code is compiled, and if any changes are found in the file, the IDE is smart enough to know to only build that file instead of building everything again. Now we can also clean our project. Cleaning the project removes intermediate and output files from the object and bin project folders. Let's say we want to clean our project, so we can take a look at the current files found in our bin folder, Netcore App 3.1. We'll see that we have our JSON files, our DLL files, and our PDB files. So if we go to Build and then clean our debug app, and then go back into our actual project directory, and then navigate straight into our bin folder, debug Netcore App 3.1, we'll see that all our files have been removed. Lastly, you can also rebuild a project. The way rebuild works is we first clean the project and then build the solution from scratch. And since the project is cleaned prior to running the build command and all intermediate and output files are removed prior to the build, we end up building the project from scratch with this one rebuild command. And rebuilding a project is very useful when we want to preserve the integrity of the build and ensure that no output files are stale if we introduce multiple dependencies over an extended period of time. So hopefully that gave you a better understanding of what happens when we run our application. Okay, so before we start debugging our app, let's take a quick look at our About page model and see what functions we have created and what we'll be doing here. First, we'll see here on line 13 that I have a public property of data type string called message with a getter and setter. Inside our onGet method here, we're assigning hello to that same property. And right after we're assigning hello to it, we're reassigning a new value to it using the add2message function. The add2message function takes an array of 3 elements and then returns a new value from it. So if we jump to the add2message function, we'll see what's happening with that method. Add2message is a private method that takes in a string array and creates a new string called result. So you'll see we start out with an empty string assigned to result, then we loop over the array that's passed into the method and append each element from the array to that result variable, which starts out as an empty string. Then after the first iteration, it will add the first element with a new line, then the second element with another line, and then the third element with another line. Once the loop is done, we're using a function created replaceToUpper that takes in that string, and we can look down here on line 41 that it converts the whole string into uppercase. Lastly, we have a divide by zero method. In this method, we have a try and catch statement where it attempts to divide by zero in the try clause, and the catch clause simply logs a message into the debugger. So now we can get into the meat of the video. We're going to start by looking into breakpoints. Now, a breakpoint indicates where Visual Studio should suspend your running code, so you can take a look at the values of variables or the behavior of memory, or whether or not a branch of code is getting run. We can place a breakpoint right next to a line number. So in our application, I'm going to go ahead and add a breakpoint in our onGet function where I assign the string hello to the property message. From here, we have a few options on how to run our application. With the debugger, we can go to Run and select Start Debugging. We can also click the Play button here, which has a debugger that will open and launch our application on a Google Chrome tab. So I'm going to go ahead and click the Play button here, and this should run a build and then run and execute our application. Once the build is successful, our application should be launched in a new Google Chrome tab. And a shortcut on a Mac to run the app with a debugger would be Alt and Command and Enter. On a Windows machine, there are a few ways you can start your application with a debugger. You can go to the Debug tab up here and select Start Debugging. The shortcut for it would also be F5. Or you could click on the Play button here on the upper right corner. So once we run the application with a debugger, we can navigate to the About page, and from there we'll be taken to our breakpoint location. So I'm going to go ahead and click on About, and we'll be taken to the breakpoint location where our code has been suspended. Once we're here, we'll see that a few windows have popped up for us. We have the locals, error, breakpoints, the watch, and the threads window. So if we go into the locals window, we'll see some information displayed on local variables and objects based on the current context or the local scope. Since we're in the About model, we'll see variables from that model and the model it inherits, which is the page model. So the keyword this is in context to that actual model. So if we're going to open up this dropdown, we'll see a bunch of properties and built-in functions that belong to the About model and the page model class. The second line here, we'll see our property message, which has a value of null, which makes sense because our code has suspended. So this line 17, where we assign the string hello to message, hasn't been actually executed yet. Now, when it comes to breakpoints, Visual Studio is very useful in providing us with 3 different types of actions that we can use on breakpoints. First thing we could do is step into, which runs the next statement. So if the current line contains a function call, step into steps into that function. The shortcut for this command on a Mac is Shift Command and I, and on Windows it is F11. We could also step over, which runs the next statement without stepping into functions or methods. And the shortcut for this on a Mac is Shift Command and O, and on Windows it is F10. And lastly, we could step out of, which advances the debugger all the way through the current function, and it continues running code and suspends execution when the current function returns. The shortcut for this on Apple is Shift Command and U, and on Windows it is Shift and F11. Back in our application, we can find options for these commands here at the top of our tab. So let's go ahead and jump over into the next statement, which is found here on line 19, where we reassign message. So next to the play button, I'm going to go ahead and click on step over, which will direct us to the next statement here on line 19. And now if we take a look at our locals windows, we'll see that message now has a value of hello because a line on line 17 was actually executed. Now here on line 19, we're making a call to the function add to message. So if we want to take a look at what's happening in there, we could step into that function. So let's click on the step into action button, and then we'll be taken to the function definition. You can see by our cursor here indicated that we're now in this code block. Since the method now has actual scope, we could also click on the parameter to see what values were passed in. So if we click here on text, we'll see a little drop down of text that contains an array containing 3 string elements. So we can actually open it up and see the values that were passed into that method. And now that we have local scope in this function, we can actually go into our locals window and find the variable text in there with some information regarding its value. We could also find it here on our watch window. So if we go into this watch window, we'll be able to track down any variables that we care about and see how they change while we're debugging our application. So we can add any kind of variable or item that we'd like. So I can double click here and add message, and you'll see the value being populated. So I can also add another one. I'll add text to see what the value of it is. And you'll see that it's actually an array containing 3 string elements. So the watch window is very useful in letting us track how these variables change, or even seeing any expression being generated. You can actually type in any kind of expression here and it will return us a value. So let's write out a string that displays the first element in the text array. So we'll type in text0 is, and then I'll type out and access the first element in the text array, and then we'll see that the value has been populated for us. It's also useful to point out if you're on a Windows machine, you can simply highlight and drag the variable into your watch window. So now let's take a look at the call stack. Now the call stack shows the order in which methods and functions are getting called, and it's a good way to examine and understand the execution flow of an app. So if you place a breakpoint in our replace to upper method here where we return text.toUpper, we can actually continue this and see the call stack. Now you won't see the call stack here, and if you by any chance close any of these tabs, you can find them by going onto View, going to Debug Paths, and then you'll see the windows that are useful for debugging. So I'm going to go ahead and click the call stack, and it should show up here. So I'm going to go ahead and expand this a little bit more. Scroll down. So now if we continue and I click on Run, we'll be taken and shown the call stack, which is basically the line of execution. So we start here on line 19 as indicated, where we make a call to add to message. Then we're taken to the add to message function. And then from here, you can see that it's highlighted. We're making another call to another method called replace to upper, which starts out here in the function definition. And then finally, it returns the text in uppercase. So our code is suspended here at the moment, meaning it hasn't returned anything. But if I click run again, our call stack should be cleared since we're returning a value from that method. So let's take another look at how the call stack actually worked. So we started in our onGet method. Within that method, we're making a call to add to message. So the add to message function call is added to the call stack. Within the add to message method, we're actually making another call to a method called replace to upper. So from there, replace to upper is added to the call stack as well. And once a value is returned from replace to upper, our call stack is cleared. So we're essentially 3 lines deep into our line of execution before we return a value. So I'm going to go ahead and close the call stack window. And now we can look at the output window. Now the output window displays status messages for various features in the IDE, and it helps us track of what's happening while the application is running. We'll find certain logs of applications running, what port we're running our application on, or packages being installed or updated. But we can use it ourselves to actually log out certain information whenever we hit a line of code. If we take a look at our divide by zero method call, here we're attempting to divide an integer by 0, which throws an exception. We can then cast the exception and write to the line a custom message. So when we continue the application, if we look on our onGet method, we notice that we made a call to divide by 0 on line 24. Since we know it's not possible to divide by 0, we caught the error, the exception, and sent a custom message to our output window. As you can see, we're using string interpolation to actually display the message, and you can see that it's outputted here in our output window where it says, oops, attempted to divide by 0. So one other handy tool we can use is to set conditionals in our breakpoints. So instead of hitting a specific breakpoint every time we run our application, we can create a condition to only hit it if a certain expression is true. So let's say we only want to stop at this breakpoint if the string argument here text contains the word first. I can do that by right-clicking on the breakpoint and then editing the breakpoint. From here, we can specify that the variable text should contain the word first. We'll have some other options provided for us, but we want to place an advanced condition to only stop at this breakpoint if the text contains the word first. So we can click on apply, and now that condition should be applied to the breakpoint. So let's go over ahead and go through the process of debugging our application again. And let's see if we actually land on that breakpoint now. So this should launch our application once more. We go ahead and click on About. We'll land on the first one where we have the message equal to hello, and we'll continue to the next one, and you'll see that we actually land on that breakpoint. Now, if I were to actually change the condition for that breakpoint where it contains something that is not in that, so I'll type in second and apply that condition, and then we go over the process again. Let's go ahead and launch our application. Go into About. Since that condition will be equal to false, then we should not land on that breakpoint. So let's go to About. We'll land on the first breakpoint, and if we click Run and Continue, you'll notice that we actually don't. We skip that breakpoint and we go straight into divide by 0, which logs out the message, oops, attempted to divide by 0. Now let's take a quick look and see how we would do this on Windows. On a Windows machine, setting a conditional on a breakpoint is a little bit different. Let's go ahead and place a breakpoint where we return the text in uppercase. We can right click, then you go to Conditions, and from here we can set any kind of condition that we like. So let's add a condition where we only want to hit the breakpoint if the text contains the keyword first. And then you'll see some configurations on the breakpoint. And you'll also notice a plus sign in the breakpoint indicating that a conditional has been applied to it. So this feature is especially useful when one is trying to catch a condition that may only occur once out of many passes, and where we want to save time and not break on each pass to check for a value that we're looking for. Okay, now let's move on to the error window. Now C# is very specific with the syntax. So let's say we forget to add a semicolon. I'm going to remove the one here on line 17 where we assign the string to message. And we try to run our application will fail to build, as indicated here at the top. So we can actually open the errors window and see where the error actually falls. So you'll see we have it really nicely formatted for us. We have basically a table that displays what the error is, the description, which file, and which line. So we'll see that on line 17 of our about.cshtml.cs file, we forgot to actually add a semicolon since it was expected here. So I'll go ahead and add it back in there. So let's make another mistake here that's very common. Let's scroll down into our divide by 0 method. Now, in order to actually use the debug object here and make a call with right line on it, we need to import the correct library namespace. Now, I already have it added at the top here on line 3, where we specify the correct namespace, which is system.diagnostics. But let's pretend we forgot to add it. So I'll remove it, and then we'll run our application and see what error is actually being displayed this time. So our build was not successful, and we'll see in the description that the name debug does not exist in the current context. Now, one thing we could do now is simply look up online where debug comes from and add the proper namespace. But there is a handy tool we can use called Quick Fix. So you'll see a red underline where the bug is located, and if we right click on it and select Quick Fix, we'll be provided with a few options on how to actually fix this bug. So you can see that we're missing an actual namespace, and Visual Studio is smart enough to let us know which one it is. So we can actually click on using System Diagnostics, and it will automatically add it to our actual code. So you'll see on line 3 it's been added now, and the red squiggly line has disappeared. Quick actions are extremely useful and not only add using statements, but help us easily refactor, generate, or otherwise modify code with a single action. And as you continue your coding journey in ASP.NET, you'll see how quick actions may come up with solutions for other types of errors. Now let's take a look at how we can actually navigate a bit more around our methods and properties. So we can actually right-click on methods and we'll be provided with a few options. So if you right-click on Add to Message and we want to know where exactly the function was declared, we can go into Go to Declaration. This will take us exactly to where the actual method was declared, as you can see by the screwdriver here on line 28. We can also see where a method was referred. So if we scroll down here into Divide by 0 and we right-click here and we go to Find References, we'll be given a search results window where we find all the references to that method. So we'll see our search results. We are declaring it here on line 46, and we're making a call here on line 24. Finally, let's assume our project is huge and we're working with a large number of folders and files. Imagine we want to look up where a certain function is called or what files are using it. We could search for that method with a search functionality. So if we click on the Search tab and go down into Find in Files, we'll be able to search any methods or variables that we want. So let's go ahead and search for Add to Message, and we'll look in our current project and let's click on Find. And here you go. You should get the search results at the bottom here where we're actually making function call on line 19 and the definition on line 28. So this covers a large chunk of the available tools that Visual Studio provides for building and debugging an application. We saw how to build, clean, and rebuild works. We also saw how useful breakpoints are in order to suspend the application in certain sections and navigate around it in the states. Debugger windows were extremely useful, and we looked at a couple of them. We looked into the call stack, which is extremely useful in seeing the flow of how methods are called and which methods are being trickled down into other ones, which is very useful to track where your application could be breaking. We used the output window in order to log certain messages from within the application. And then we look into the error window, which provides us a more detailed information regarding any errors found in our code by displaying the line, the description, and what possible solutions we can actually give. Lastly, we took a look at some useful quick action features like Quick Fix in order to modify our code with a few simple clicks. And finally, we looked into how to find method declarations or references by simply right-clicking on them and selecting Jump to Definitions or Find References. Now, these tools are extremely valuable in helping solving issues around the application, but most importantly, remember to read the error messages. Oftentimes, our application could be breaking because we forgot to add a comma somewhere. So error messages could save us a lot of time by letting us know on what line an error was found and a description of it. So I hope this video gave you a good understanding on how to debug your application. Thanks to everyone who watched, and I'll see you all next time.